Welcome to where time falls quiet.
Did a comet end Atlantis? Plato's 11,600-year clue. Take a moment to subscribe, so this place of calm is always here for you. What if the most ridiculed legend in Western civilization was actually the oldest testimony of a real catastrophe? What if Atlantis was not invented by Plato as a philosophical allegory, but inherited by him as corrupted history, a story that had already survived 4,000 years of retelling before he ever put stylus to wax? This is not the typical Atlantis video you have encountered before, filled with speculation about alien technology or mystical crystal power grids. This is something else entirely. A forensic examination of what happens when you stop treating ancient testimony as primitive fantasy and start treating it as eyewitness evidence, preserved against impossible odds of a world that drowned. Here is what we know, and what Orthodox history prefers you do not think about too carefully. Between 12,900 and 11,600 years ago, the Earth experienced a climate catastrophe so severe that it has its own name in the geological record, the Younger Dryas. This was not a gradual shift or a regional drought. This was a planetary reset, a return to full Ice Age conditions that happened not over millennia, but within a human lifetime, perhaps within a single generation. Temperatures plummeted. Ice sheets that had been retreating for thousands of years suddenly advanced again. Megafauna that had survived the end of the last ice age, mammoths and saber-toothed cats and giant ground sloths, went extinct across entire continents in what appears to have been ecological synchrony. The mechanism that triggered this cataclysm is still debated, but the evidence is accumulating in layers of sediment, in ice cores pulled from Greenland, in the chemistry of ancient lake beds. Something struck the Earth or exploded in its atmosphere with enough force to destabilize the climate system of the entire planet. Nanodiamonds, microscopic spherules formed only under extreme heat. Platinum anomalies and shocked quartz appear in sediment layers dated to the Younger Dryas boundary on multiple continents. This is not the fingerprint of gradual climate change. This is the signature of impact, of cosmic collision, of fire raining from the sky. And if you overlay the timeline of this geological trauma with the timeline Plato gave for the destruction of Atlantis, they align with unsettling precision. 9,600 years before his time, which places the event at 11,600 years ago, the exact termination point of the Younger Dryas. Now, hold that thought, because what we are about to do is not accept this coincidence, but interrogate it with the same rigor we would apply to any other historical claim. We're going to examine Plato's account not as myth, but as a document requiring verification. We are going to look at the flood legends preserved by over 200 cultures across the planet, separated by oceans and millennia, yet describing the same sequence. Advanced societies, moral decay, divine warning, and then the deluge that erased the world. We are going to descend into underwater ruins off the coasts of Japan, India, and the Mediterranean. Structures that were above sea level during the Ice Age but now lie 300 feet beneath the surface, drowned when the ice sheets collapsed and the oceans rose. We are going to stand in front of Göbekli Tepe, a temple complex in Turkey that was deliberately buried 11,600 years ago by people who had not yet supposedly invented agriculture, pottery, or writing, yet somehow possessed the engineering knowledge to move stones weighing over 10 tons and carve them with astronomical precision. This is not a story about proving Atlantis existed in the sense of finding a sunken city with that exact name inscribed on a marble column. This is a story about pattern recognition. It is about asking why the earliest civilizations that emerge into the light of recorded history, Sumer, Egypt, the Indus Valley, appear already sophisticated, already in possession of mathematical knowledge, astronomical observations, and architectural techniques that seem to have no developmental precursor. It is about confronting the possibility that what we call the beginning of civilization might actually be its resumption, the slow rebuilding after a collapse so total that most of the evidence was erased, either by the rising seas that drowned the coastlines, where advanced societies would have thrived, or by the passage of 12,000 years, which is more than enough time to turn stone back into sand and metal back into rust. The Orthodox narrative tells us that civilization began around 5,000 years ago in Mesopotamia, that everything before that was primitive hunter-gatherer societies living in small bands, developing slowly toward agriculture and urbanization. But this narrative requires us to ignore the anomalies that keep appearing in the archaeological record, like cracks in a dam. It requires us to dismiss the mathematical sophistication of Sumerian tablets that calculate planetary orbits and contain trigonometric tables identical to modern algorithms. It requires us to overlook the precision of the Great Pyramid, aligned to true north within 3/60ths of a single degree, incorporating the dimensions of the Earth itself into its geometry. It requires us to explain away the fact that cultures on opposite sides of the planet with no supposed contact built massive stone structures using identical techniques, moving blocks weighing hundreds of tons with a precision that modern engineers struggle to replicate, even with cranes and computers. What if these are not coincidences, but inheritance? What if these early civilizations were not inventing knowledge, but recovering it, piecing together fragments of information that had survived the catastrophe encoded in myth, in measurement systems, in the dimensions of sacred architecture? What if Plato was not creating a fictional utopia to illustrate a political point, but preserving a memory that had been passed down through Egyptian priests, who themselves had inherited it from older sources, a testimony of a world that ended not in metaphor, but in flood, fire, and geological upheaval? This is the hypothesis we are going to explore, not as certainty, but as narrative, a thread that connects the geological record of the Younger Dryas to the myth of Atlantis, and both of them to the inexplicable sophistication of the earliest known civilizations. We are going to treat ancient testimony with the same seriousness we grant to any other form of evidence. We are going to ask what it means if the flood was not a convenient literary device invented by priests to control populations, but a historical event so traumatic that it became the foundational story of human culture, retold in every tradition, because it was the one story that could not be forgotten. We are going to examine whether the survivors of that catastrophe carried with them not just their lives, but their knowledge, their astronomy, their engineering, their understanding of cycles and cataclysms, and whether that cargo of memory became the seed from which the next age of civilization grew. Because here is what makes this more than speculation, more than the usual fringe theorizing that fills the internet with pseudoscience and wishful thinking. The evidence is multidisciplinary. It comes from geology, climatology, archaeology, linguistics, astronomy, and the study of ancient texts. It comes from ice cores and sediment samples, from underwater sonar scans and megalithic ruins, from mathematical tablets and flood myths. None of these fields alone proves the hypothesis, but together they create a pattern that orthodox history has not adequately explained, a convergence of anomalies that points toward a single possibility: that human civilization is older than we have been taught, that it has risen and fallen before, and that the memory of that fall is preserved not in academic journals, but in the oldest stories we still tell. The question is not whether Atlantis was real in the literal sense of matching every detail Plato recorded. The question is whether Atlantis is a name, perhaps corrupted through millennia of translation, for something that was real, an advanced society that existed during the Ice Age, that thrived on coastlines now submerged, that possessed knowledge we assume was impossible for that era, and that was destroyed when the Younger Dryas cataclysm struck, when the climate collapsed, when fire fell from the sky, when the ice melted and the seas rose, and an entire world drowned, leaving only fragments, whispers, and ruins for us to find 12,000 years later. That is the story we are going to tell, not with certainty, but with evidence, not with answers, but with questions that refuse to be silenced, because the past is not silent. It whispers through the present in the form of anomalies, contradictions, and mysteries that the standard narrative cannot resolve. And if we listen carefully, if we stop dismissing what makes us uncomfortable, we might hear something that changes everything we thought we knew about where we came from and what we have forgotten. The story of Atlantis appears in two of Plato's dialogues, written around 360 BCE, the Timaeus and the Critias. Orthodox scholarship has treated these texts as philosophical fiction for over 2,000 years, allegories designed to illustrate Plato's theories about ideal government and the corruption of power. But that interpretation requires something remarkable. It requires us to believe that Plato, when creating his fictional utopia, chose to fill it with the kind of mundane, technical, and oddly specific details that characterize historical testimony rather than literary invention. It requires us to explain why a philosopher constructing a moral parable would bother to specify the exact dimensions of harbour walls, the precise layout of irrigation canals, the metallurgical composition of building materials, and the geographical coordinates of a lost island with the kind of clinical precision normally reserved for surveyor reports and engineering documents. Plato claims he received the story from his ancestor Solon, the Athenian lawgiver who travelled to Egypt around 590 BCE. There, in the city of Sais, Egyptian priests told Solon about a war between ancient Athens and Atlantis that occurred 9,000 years before their conversation, which places the event at approximately 9,600 BCE. The priests describe Atlantis as a massive island empire located beyond the Pillars of Hercules, what we now call the Strait of Gibraltar, in the Atlantic Ocean. They explain that this civilization possessed advanced engineering, a sophisticated navy, and territorial ambitions that extended across the Mediterranean. Then, in a single day and night of catastrophic earthquakes and floods, Atlantis sank beneath the sea and disappeared, taking its people, its culture, and its memory into the depths. Now, here is where the text stops reading like allegory and starts reading like something else entirely. Plato, or rather the Egyptian priests through Solon through Plato, provides measurements. The central island of Atlantis was 50 stadia in diameter, roughly 5.5 miles. It was surrounded by alternating rings of land and water. 3 rings of water and 2 rings of land, each precisely measured. The outermost ring of water was 3 stadia wide, approximately 1,000 feet. The rings of land were proportionally larger, creating a concentric pattern of defense and irrigation that required engineering on a scale that would challenge modern hydraulic systems. The capital city sat at the center of these rings, connected to the sea by a canal 50 stadia long, wide enough and deep enough to accommodate the largest ships of the ancient world. The level of architectural detail continues with almost bureaucratic thoroughness. The walls of the city were constructed from 3 types of stone: red, white, and black, quarried from the island itself. These walls were covered in metals, with the outer wall plated in brass, the middle wall in tin, and the inner wall in orichalcum, a metal that Plato describes as second only to gold in value, and which glowed with a reddish light. The royal palace at the centre contained hot and cold springs, public baths, elaborate gardens, and temples dedicated to Poseidon decorated with gold, silver, ivory, and the mysterious orichalcum. The temple itself measured 1 stadium in length, 3 plethra in width, and was proportionally tall, dimensions that suggest a structure comparable in scale to the largest cathedrals of medieval Europe. But the precision does not stop with architecture. Plato describes the military organization of Atlantis with the specificity of a war census. The island was divided into 60,000 military districts, each required to provide a specific quota of warriors, chariots, horses, and naval vessels. The total military force numbered 1,200,000 infantry, 10,000 chariots, and 1,200 warships. These are not the vague, inflated numbers of myth and legend, where armies number in the millions simply to convey power. These are logistical calculations, the kind of figures that appear in administrative records when someone is actually trying to track resources and mobilization capacity. Then there is the agricultural system. Plato describes a vast rectangular plain behind the capital. Measuring 3,000 stadia by 2,000 stadia, approximately 215 miles by 143 miles. This plain was crisscrossed by a network of irrigation canals arranged in a perfect grid, each canal 100 feet wide and running both longitudinally and laterally across the entire plain. The canals connected to the sea, allowing for transport of timber and seasonal crops. The amount of engineering required to construct and maintain such a system, moving water across hundreds of miles of terrain, suggests a level of hydraulic knowledge that most historians associate with civilizations like Rome at its peak, not with a supposedly fictional island from before recorded history. What makes this detail so unsettling is its mundanity. When authors invent fictional places, they focus on the exotic, the fantastical, the elements that will capture imagination. They describe magical properties, divine interventions, impossible wonders. They do not spend paragraphs explaining irrigation canal dimensions, military conscription quotas, and the 3-ring system of harbour fortifications. Those are the kinds of details that appear in historical accounts because the author is trying to reconstruct something real, something they heard about but never saw, something they are attempting to preserve with as much accuracy as limited information allows. The timeline Plato provides is equally specific and equally problematic. The Egyptian priests tell Solon that the war between Athens and Atlantis occurred 9,000 years before their conversation. Orthodox historians dismiss this number as impossible, arguing that no civilization existed 9,000 years before Solon, let alone one capable of naval warfare and imperial expansion. But that dismissal requires us to ignore what we now know about the state of the world in 9600 BCE. This date falls within the late Younger Dryas period, just before the climate stabilized and just before the catastrophic meltwater pulses that raised global sea levels by over 400 feet. It places Atlantis at exactly the moment when coastal civilizations, if they existed, would have been most vulnerable to destruction by rising waters. Moreover, Plato's account includes a detail that should not exist if the story were pure invention. He states that after Atlantis sank, the sea in that region became impassable due to shoals of mud, just below the surface, preventing ships from sailing through. For centuries, this was dismissed as absurd. How could an entire ocean become unnavigable? But we now know that the Mid-Atlantic Ridge, a massive underwater mountain range, does have sections where volcanic sediment and geological debris create shallow zones that would have been hazardous to ancient navigation, particularly if recent seismic activity had altered the sea floor. Plato could not have known about the Mid-Atlantic Ridge. No ancient Greek had the technology to map underwater geology. Yet he includes a detail about post-cataclysm ocean conditions that aligns with features we only discovered with modern sonar. The metallurgy presents another anomaly. Orichalcum, the mysterious glowing metal that Plato describes as covering the walls of Atlantis, has been dismissed as fantasy, a made-up substance to add mystique to the story. But in 2015, ingots of a copper-zinc-brass alloy were recovered from a shipwreck off Sicily, dated to the 6th century BCE. The composition matched descriptions of orichalcum from ancient texts, and the metal did have a distinctive golden red appearance when polished. The existence of this alloy does not prove Atlantis was real, but it does prove that the materials Plato described were not imaginary. They were real metallurgical products of the ancient world, which raises the question, why would he use a real, specific alloy if he were inventing a fictional civilization? Then there is the matter of the concentric ring structure. This is not a common architectural pattern in Greek city planning. Greek cities were typically built on hills or acropolis formations with irregular organic layouts. But concentric ring cities do appear in the archaeological record, particularly in pre-Columbian America and ancient Mesopotamia. The ancient city of Poverty Point in Louisiana, built around 1500 BCE, consists of 6 concentric semicircular ridges. The Sumerian city of Uruk had ring-structured defensive walls. The city of Ecbatana, capital of the Median Empire, was described by Herodotus as having 7 concentric walls, each painted a different color. Plato's description of Atlantis fits this pattern of real architectural design, not the creative invention of a philosopher with no engineering experience. What we are left with is this. Either Plato, constructing a fictional allegory, chose to fill it with mundane technical specifications, real metallurgical materials, logistically plausible military figures, and geographical details that align with actual ocean topography, all for no apparent literary purpose. Or he was preserving a story that came to him already filled with those details, a story that had survived not as mythology but as corrupted history, passed down through Egyptian records that themselves were copies of older sources, testimony to something that was real enough that people felt compelled to measure it, to record its dimensions, to preserve its specifications, even after the thing itself had vanished beneath the waves. The precision is not proof, but it is a question that refuses easy dismissal. It is the whisper of something that demands we listen more carefully to what the ancient world was trying to tell us. Between 12,900 and 11,600 years ago, something happened to the Earth that does not fit comfortably into our understanding of gradual climate change. The planet, which had been warming steadily for thousands of years as the last ice age retreated, suddenly reversed course and plunged back into full glacial conditions. This was not a slow drift toward cooler temperatures or a regional anomaly affecting a single continent. This was a planetary emergency, a climate whiplash so severe and so rapid that it left a scar in every geological archive we have learned to read. Ice cores from Greenland, sediment layers from lake beds, pollen records from peat bogs, and the bones of extinct animals flash frozen in permafrost. The event has a name in the scientific literature, the Younger Dryas, named after an Arctic alpine flower called Dryas octopetala, that suddenly reappeared in European pollen records when tundra conditions returned. But the name is almost inappropriately delicate for what the evidence describes. Temperatures in the northern hemisphere dropped by an average of 15 degrees Celsius within a single decade, perhaps within a single generation. Ice sheets that had been retreating for millennia stopped, stabilized, and in some regions began advancing again. The North Atlantic, which had been warming and supporting increasingly temperate conditions, became choked with icebergs and freshwater from melting glaciers, disrupting the ocean currents that regulate global climate. The sudden influx of glacial meltwater shut down the thermohaline circulation, the massive conveyor belt of ocean currents that redistributes heat around the planet, plunging Europe and North America into conditions comparable to the depths of the Ice Age. This was not theoretical climate modeling or abstract projections about parts per million of atmospheric carbon. This was observable, measurable physical trauma recorded in layers of ice and sediment. When scientists drill ice cores from the Greenland ice sheet, they are extracting a chronological record of atmospheric conditions going back over 100,000 years. Each layer of ice contains trapped air bubbles, microscopic samples of the ancient atmosphere, along with dust, volcanic ash, and chemical signatures that reveal temperature, precipitation, and even the intensity of solar radiation. The Younger Dryas boundary appears in these cores as a stark transition, a line where the isotopic ratios of oxygen shift abruptly, where dust concentrations spike, where the temperature record shows a cliff edge drop that happens not over centuries, but over years. The ice does not record gradual change. It records catastrophe. The same signature appears in sediment cores taken from lake beds across North America, Europe, and Asia. At a depth corresponding to approximately 12,900 years ago, researchers find a distinct layer, often darker than the sediment above and below it, rich in carbon and sometimes containing unusual concentrations of magnetic particles. This layer, informally called the black mat by archaeologists, marks a boundary between two worlds. Below the black mat, evidence of human habitation is abundant. Tools, hearths, the bones of animals that were hunted and consumed. Above the black mat, many of these sites show abandonment, a sudden cessation of human activity that aligns precisely with the climate collapse. The sediment does not just record environmental change. It records the consequences of that change on the people who lived through it. But the climate reversal was only one aspect of the catastrophe. Across the northern hemisphere, dozens of species of megafauna, animals that had survived the end of the last ice age, went extinct within a narrow window of time that coincides with the onset of the Younger Dryas. Woolly mammoths, which had roamed the Arctic for hundreds of thousands of years, disappeared. Mastodons, giant ground sloths, saber-toothed cats, dire wolves, short-faced bears, American camels, and horses all vanished from the fossil record. The extinction was not limited to North America. In Europe, the woolly rhinoceros and the cave bear went extinct. In Australia, the last of the megafauna, including giant kangaroos and marsupial lions, disappeared around the same time. This was not slow attrition from changing habitats. This was synchronized ecological collapse across continents separated by oceans. The most haunting evidence comes from Siberia, where the remains of mammoths have been found preserved in permafrost, with undigested vegetation still in their stomachs and mouths. These animals were feeding, grazing on tundra plants, when they died. They did not starve slowly or succumb to disease over weeks or months. They froze, rapidly enough that their soft tissue, their muscle, their organs, were preserved before decomposition could occur. Some specimens show evidence of having been flash frozen, their cells ruptured by the formation of ice crystals, a process that requires temperatures to drop suddenly and dramatically. The permafrost did not gradually entomb these creatures over generations. It took them in an instant, or near enough to an instant that the difference becomes meaningless. The question that has consumed researchers for decades is simple. What could cause a climate system as massive and stable as Earth's to reverse course so violently and so quickly? Gradual orbital variations, the Milankovitch cycles that govern Ice Age timing, operate on scales of tens of thousands of years. Volcanic eruptions can cause temporary cooling by ejecting sulfur dioxide into the stratosphere, but those effects last a few years at most, not the 1,300 years that the Younger Dryas persisted. The shutdown of the thermohaline circulation could explain the cooling in the northern hemisphere, but something had to trigger that shutdown. Something had to dump enough fresh water into the North Atlantic to disrupt the ocean currents. For years, the prevailing hypothesis was that a massive glacial lake in North America, Lake Agassiz, which had formed behind retreating ice sheets, suddenly drained into the ocean when an ice dam failed, releasing enough meltwater to disrupt the Atlantic circulation. But that hypothesis has problems. The timing of the Lake Agassiz drainage does not align precisely with the Younger Dryas onset. More critically, the meltwater pulse theory does not explain the evidence of widespread fire, the carbon-rich black mat layer found across North America, or the presence of exotic materials in the Younger Dryas boundary layer. Nanodiamonds, microscopic diamonds that form only under extreme pressure and temperature. Shocked quartz, mineral grains showing fracture patterns characteristic of high-velocity impact. Platinum anomalies, concentrations of this rare element at levels hundreds of times higher than background. And magnetic spherules, tiny beads of melted rock and metal that form when material is subjected to temperatures exceeding 2,000 degrees Celsius. These are not the signatures of glacial meltwater. These are the signatures of cosmic impact. The hypothesis that has been gaining traction, supported by a growing body of evidence, is that Earth was struck by fragments of a disintegrating comet at the onset of the Younger Dryas. The impactors may have been multiple airbursts similar to the Tunguska event of 1908, but occurring simultaneously across a continental scale, or actual surface impacts that struck ice sheets and oceans, leaving little in the way of traditional craters, but triggering massive atmospheric disturbances, wildfires, and the injection of enough dust and aerosols into the upper atmosphere to block sunlight and initiate rapid cooling. The meltwater that shut down the ocean currents may not have come from a glacial lake, but from ice sheets destabilized by direct impact, or by the thermal effects of airbursts melting billions of tons of ice in a matter of hours or days. This is not fringe speculation divorced from evidence. The materials found in the Younger Dryas boundary layer have been identified at dozens of sites across multiple continents, analyzed in peer-reviewed studies by geologists, physicists, and archaeologists. The debate is not about whether these exotic materials exist, but about what mechanism placed them there. And as the data accumulates, as more sites are excavated and more samples are analyzed, the impact hypothesis becomes harder to dismiss. The Earth was struck, the climate collapsed, the megafauna died. And if human civilizations existed on the coastlines during the Ice Age, as the evidence from submerged ruins and flood myths suggests, then they were in the direct path of the catastrophe. They would have witnessed the sky burning, the ice melting, the seas rising, and the world ending within their lifetimes. They would have had every reason to remember it, to encode it in myth, to warn future generations that the stability we take for granted is an illusion, and that catastrophe is not an anomaly, but a recurring feature of planetary existence. The Younger Dryas was not climate change. It was climate annihilation. And it happened exactly when Plato said, Atlantis drowned. Imagine walking across the American Southwest, the deserts of Arizona or New Mexico, and stopping at one of the dozens of archaeological sites that dot the landscape. You dig down through layers of sand and soil, through strata that represent thousands of years of accumulated time, and at a specific depth, approximately 12 feet below the surface. Depending on the location, you encounter something that should not exist. A thin, dark layer of sediment, rich in carbon, sometimes only a few inches thick, that appears at site after site across thousands of miles of terrain. This layer, informally known as the black mat, is not unique to the American Southwest. It appears across North America, from Canada to Mexico, from the Atlantic coast to the Pacific. It appears in Europe, it appears in the Middle East, and everywhere it appears, it marks the same thing. A boundary between worlds, the line where one chapter of human history ended and another struggled to begin. The black mat is not metaphor. It is stratigraphy, a physical layer in the archaeological record that can be touched, sampled, analyzed, and dated. Its composition varies slightly by location, but the pattern remains consistent. Elevated concentrations of carbon, often interpreted as evidence of widespread biomass burning. Magnetic particles and microspherules, tiny beads of melted material that form under extreme heat. And in many locations, an absence of the pollen and plant remains that characterize the layers immediately below it, suggesting a dramatic shift in vegetation and climate. The layer dates consistently to the onset of the Younger Dryas, 12,900 years ago. And it represents something that orthodox archaeology has struggled to explain. Synchronized environmental trauma on a continental, possibly global, scale. Beneath the black mat, evidence of human activity is abundant. The Clovis culture, named after the distinctive spear points first discovered near Clovis, New Mexico, flourished across North America during the late Pleistocene. These were not primitive hunter-gatherers scraping by at the edge of survival. The Clovis people were sophisticated stone tool manufacturers, creating projectile points with such precision and artistry that modern flint knappers struggle to replicate their techniques. They hunted megafauna, mammoths and mastodons, using cooperative tactics that required planning, communication, and intimate knowledge of animal behavior. Their camps and kill sites stretch from the Atlantic to the Pacific, from the Great Plains to the forests of the Southeast, evidence of a population that had successfully adapted to the diverse environments of an Ice Age continent. Then, at the black mat boundary, everything changes. Above the layer, Clovis points disappear from the archaeological record. The megafauna they hunted go extinct within the same narrow time window. Many sites show complete abandonment, a cessation of human occupation that lasts for generations. When human activity resumes, it is different, represented by new tool technologies and new cultural patterns, as if the people who returned were not the same people who left, or as if so much knowledge had been lost in the interim that they had to rebuild their survival strategies from fragments. The black mat is not just a geological curiosity. It is a crime scene, and the evidence suggests that whatever happened at this boundary was catastrophic enough to disrupt human societies across an entire hemisphere. The carbon content of the black mat tells part of the story. When organic material burns, whether forest, grassland, or animal tissue, it leaves behind carbon residue. The concentrations found in the black mat layer suggest extensive fires, not localized burns but continent-scale conflagrations. Some researchers have proposed that these fires were the result of human activity, perhaps overhunting leading to ecosystem collapse, or climate change causing droughts that made landscapes more vulnerable to wildfire. But those explanations struggle to account for the synchronicity. Fires caused by drought or human mismanagement would occur gradually, spread across decades or centuries as conditions worsened. The black mat appears simultaneously across thousands of miles, suggesting an ignition source that was not gradual but instant. Something that could start fires across an entire continent at the same time. This is where the exotic materials become critical. Within the black mat layer, researchers have identified materials that do not belong in normal sedimentary deposits. Nanodiamonds, carbon structures only a few nanometers in size, form under conditions of extreme pressure and temperature, typically during meteor impacts or nuclear explosions. They have been found at over 50 sites across North America, Europe, and the Middle East, all within the Younger Dryas boundary layer. Shocked quartz, mineral grains showing distinctive planar fracture patterns, form when quartz crystals are subjected to pressures exceeding 10 gigapascals, conditions that occur naturally only during meteorite impacts or underground nuclear detonations. Magnetic spherules, tiny beads of iron and silicate that form when rock and metal are melted and rapidly cooled, appear in concentrations far exceeding background levels. And platinum, a rare element associated with cosmic material, shows anomalous spikes at the boundary, sometimes reaching concentrations 100 times higher than in the surrounding sediment. These materials do not form from forest fires, climate change, or normal geological processes. They are the fingerprints of impact, the residue left when extraterrestrial objects enter the atmosphere at hypersonic velocities and either explode in airbursts or strike the surface directly. The distribution of these materials across multiple continents suggests not a single impact, but multiple impactors. Perhaps fragments of a disintegrating comet striking the Earth in a cosmic shotgun blast that lasted hours or days. Each airburst would have released energy equivalent to multiple nuclear weapons, igniting fires across hundreds of square miles, generating shockwaves that flattened forests and shattered stone, and injecting massive amounts of dust, soot, and aerosols into the upper atmosphere. The consequences would have been immediate and apocalyptic. The fires alone would have consumed vast stretches of forest and grassland, destroying habitat and food sources for both animals and humans. The atmospheric loading of particulates would have blocked sunlight, causing temperatures to plummet and triggering the climate reversal that characterizes the Younger Dryas. If some of the impact struck the Laurentide ice sheet, which covered much of Canada and the northern United States during the late Pleistocene, they would have melted billions of tons of ice in a matter of hours, releasing catastrophic floods and dumping enough fresh water into the North Atlantic to shut down the thermohaline circulation. The ocean currents that regulate global climate would have stalled, plunging the northern hemisphere into glacial conditions, even as the southern hemisphere continued to warm. For anyone living through this event, the experience would have been incomprehensible. The sky would have burned. Objects would have fallen from above, exploding with force sufficient to level entire regions. The temperature would have dropped within days or weeks, turning summer into winter and winter into something worse. The animals they hunted would have died, not just individual herds but entire species, erased from existence within a single generation. If coastal settlements existed, and the evidence suggests they did, they would have watched the ice melt and the seas rise, drowning everything they had built, forcing them inland to compete for dwindling resources with populations already struggling to survive the climate collapse. This was not a natural disaster in the sense of a flood or earthquake that destroys a city, but leaves the world intact. This was planetary catastrophe, the kind of event that resets civilizations and erases memory. The black mat is evidence of that reset, a physical marker of the moment when the world broke. It appears at sites where humans lived, where they made tools and built fires and told stories to their children. And then, abruptly, those sites go silent. The people either died, fled, or adapted to conditions so harsh that their material culture became nearly invisible in the archaeological record. When the layer ends, when the climate finally stabilized 11,600 years ago, the world that emerged was not the world that existed before. The megafauna were gone. The Clovis culture was gone. The coastlines had shifted, drowned under hundreds of feet of seawater that had previously been locked in ice. And if there had been civilizations, advanced societies that thrived on those now submerged coasts during the Ice Age, they were gone too, leaving only whispers in flood myths and fragments in the ruins that divers would find millennia later beneath the waves. The black mat is not theory. It is physical evidence, a layer of sediment that can be visited, excavated, and analyzed by anyone with the tools and the will to look. It exists at Murray Springs in Arizona, at Blackwater Draw in New Mexico, at Topper in South Carolina, at dozens of sites across North America and beyond. It marks a boundary that orthodox archaeology acknowledges but struggles to explain, a moment when something happened that was severe enough to leave a permanent scar in the geological record. The question is not whether the catastrophe occurred. The question is what it destroyed and whether the survivors remembered. There are over 200 flood myths preserved in human cultures across the planet. This is not a disputed number or a matter of interpretation. Anthropologists, folklorists, and comparative mythologists have catalogued these narratives from societies separated by oceans, mountain ranges, and millennia of independent development. They appear in Mesopotamia and Egypt, in India and China, among the indigenous peoples of North and South America, in the Pacific Islands, in Aboriginal Australia, and in the oral traditions of sub-Saharan Africa. The orthodox explanation for this ubiquity is that floods are common natural disasters, and therefore it is unsurprising that many cultures would develop stories about catastrophic inundations. But that explanation collapses when you examine the details, because these myths do not simply describe local floods or seasonal river overflows. They describe the same sequence of events, the same moral framework, the same trajectory of civilization destroyed and humanity forced to begin again. The pattern is consistent and disturbing. The myths describe advanced societies, populations living in cities or organized settlements, possessing knowledge of agriculture, metallurgy, writing, or other technologies that distinguish them from hunter-gatherer bands. These societies become corrupt, morally degraded, or arrogant, forgetting the natural order or offending the divine powers. A warning is issued sometimes to a single righteous individual or family, sometimes to the entire population. The catastrophe is imminent. The warning is ignored or dismissed by the majority. Then comes the deluge, not as rain that accumulates over weeks, but as a sudden, overwhelming inundation that drowns the world, erases cities, kills populations, and leaves only a handful of survivors who must preserve what knowledge they can and restart civilization from fragments. The Mesopotamian version, recorded in the Epic of Gilgamesh, and earlier in the Atrahasis epic, describes Utnapishtim, a man warned by the god Enki that the other gods plan to destroy humanity with a flood. Utnapishtim builds a massive boat, sealed with bitumen, and loads it with his family, craftsmen, and animals. The flood arrives with violence that terrifies even the gods, described as lasting 7 days and 7 nights. When the waters recede, Utnapishtim's boat comes to rest on a mountain, and he sends out birds to test whether the land has dried. The gods, realizing they have nearly destroyed all of humanity, grant Utnapishtim immortality as compensation. The narrative contains specific details: the dimensions of the boat, the materials used in its construction, the duration of the flood, the geographical location of the landing site. These are not vague mythological flourishes. They read like survival instructions. The Hebrew version in Genesis follows the same pattern with remarkable precision. Noah is warned by God that a flood will destroy the earth due to human wickedness. He is instructed to build an ark with exact specifications: 300 cubits long, 50 cubits wide, 30 cubits high, constructed from gopher wood and sealed with pitch. He brings his family and breeding pairs of animals aboard. The flood lasts 40 days and 40 nights, though the waters remain high for 150 days total. The ark comes to rest on Mount Ararat. Noah sends out a raven and then a dove to test for dry land. The similarities to the Mesopotamian version are so striking that scholars have debated for centuries whether one borrowed from the other or whether both inherited the story from an earlier, common source. But the flood myth does not stop in the Middle East. In India, the Matsya Purana describes Manu, warned by a fish that later reveals itself as the god Vishnu, that a great flood will destroy all life. Manu builds a boat, and when the flood comes, the fish tows the boat to safety, securing it to a mountain peak until the waters subside. In China, the Gunyu myth describes catastrophic floods that threaten to destroy civilization, requiring the intervention of Yu the Great, who spent 13 years draining the waters and establishing channels to prevent future inundation. The Chinese version is less explicitly divine, framed as a natural disaster requiring human engineering, but the core remains: a world-threatening flood, followed by the restoration of order through preservation of knowledge. Cross the Pacific, and the pattern continues. The Hopi of North America describe multiple worlds, each destroyed when humanity became corrupt. The third world was destroyed by water, a great flood that drowned the wicked, while the righteous survived by climbing inside hollow reeds that floated on the surface. The Lakota tell of a time when the waters rose and covered the earth, drowning all but a few who escaped to high ground. The Aztec cosmology describes the fourth sun, Nahui-Atl, which ended in a catastrophic flood that turned humans into fish. In South America, the Muisca people of Colombia recount the legend of Bochica, a bearded teacher who appeared after a great flood to help survivors rebuild their civilization by teaching them agriculture, law, and the arts. In the Pacific, the Hawaiian legend speaks of a great flood sent by the god Cain to punish humanity, with only a few survivors who repopulated the islands. In Aboriginal Australia, numerous tribes preserve stories of the time when the sea rose and drowned the coastal lands, forcing people to flee inland. The Gunwingu people describe how the sea was once land where they hunted kangaroo, but the water came and took it, and now their ancestors' territory lies beneath the waves. These are not abstract myths about divine punishment. They are descriptions of real geographical change, of coastlines that existed and then disappeared, of hunting grounds that became ocean. The global distribution of these myths cannot be explained by independent invention unless we accept that every culture, without contact, happened to invent the same narrative structure, the same moral framework, and the same sequence of warning, destruction, and survival. The more plausible explanation is that these myths are memory, corrupted by time and filtered through different cultural lenses, but ultimately describing the same event. They are testimony to a catastrophe that was global in scope, severe enough to traumatize every surviving population, and significant enough that preserving the memory became a cultural imperative, encoded in the most sacred narratives each society possessed. What makes this convergence even more compelling is the consistency of certain specific details. Many of the myths specify that the flood was not merely rain, but a combination of rain from above and waters rising from below, suggesting both atmospheric and oceanic sources. This matches what we would expect from the Younger Dryas scenario: impacts or airbursts causing immediate atmospheric disturbance and precipitation, combined with catastrophic meltwater pulses from destabilized ice sheets raising sea levels rapidly. Several myths describe the floodwaters as hot or boiling, which aligns with the thermal effects of cosmic airbursts heating the atmosphere and surface waters. Others mention fire before the flood, describing the sky burning or stars falling, imagery consistent with meteor showers or impact events preceding the inundation. The myths also share a preoccupation with preserving knowledge. The survivors are not chosen randomly. They are described as righteous, wise, or specially instructed by divine beings. They are told to save not just themselves, but representatives of all species, craftsmen, or sacred objects. This emphasis on preservation suggests that the original event was understood not just as a natural disaster, but as a threat to civilization itself, to accumulated knowledge that took generations to acquire. The survivors were tasked with being vessels of memory, carriers of skills and information that would otherwise be lost. This is not the kind of detail that emerges from myth-making about ordinary floods. This is the kind of detail that emerges from real cultural collapse. When societies watched their cities drown and understood that if they did not actively preserve what they knew, it would vanish forever. The orthodox dismissal of these myths as independent inventions requires us to believe in coincidences stacked upon coincidences. It requires us to accept that cultures with no contact all happened to invent stories about advanced civilizations destroyed by floods. All included warnings ignored by the majority. All emphasized the preservation of knowledge by a chosen few. All described the flood as combining rain and rising waters. All set the event in a distant past that predates their own civilization's beginning. The alternative is simpler and more disturbing. The myths remember what history forgot. They preserve, in the only format available to pre-literate societies, testimony to an event that was real, that was global, that destroyed civilizations, and that forced humanity to rebuild from scattered survivors, carrying fragments of lost knowledge. The myths are not allegory. They are archive. And if we listen to what they are saying, they are warning us that the catastrophe was not unique, that it has happened before, and that the cycle of forgetting and remembering, of building and drowning, is older than we dare admit. In 1994, a German archaeologist named Klaus Schmidt began excavating a site in southeastern Turkey that would fundamentally challenge everything Orthodox archaeology believed about the development of human civilization. The site was called Göbekli Tepe, meaning potbelly hill in Turkish, and local farmers had known about it for generations, finding worked stones in their fields and assuming they were looking at the remains of a medieval cemetery. But when Schmidt began systematic excavation, what emerged from beneath centuries of accumulated soil was not a cemetery, not a medieval structure, and not anything that should have existed according to the established timeline of human progress. What emerged was a temple complex, massive and sophisticated, built 11,600 years ago by people who were not supposed to have the knowledge, organization, or motivation to construct such monuments. The site consists of multiple circular and oval structures, each containing massive T-shaped limestone pillars arranged in rings. These are not small stones. The pillars range from 10 to 20 feet in height and weigh between 10 and 20 tons each. Some are carved with elaborate reliefs depicting animals: lions, foxes, boars, snakes, scorpions, vultures, and spiders, rendered with artistic skill that suggests intimate observation and cultural significance. The pillars are not randomly placed. They are positioned according to precise geometric arrangements, with the largest pillars typically occupying the center of each enclosure, surrounded by smaller pillars forming circles or ovals. The entire complex demonstrates planning, mathematical understanding, and engineering capability that orthodox archaeology associates with settled agricultural societies, not with the hunter-gatherers who supposedly inhabited this region in the 10th millennium BCE. Here is what makes Göbekli Tepe profoundly unsettling to the standard narrative. It predates agriculture. Radiocarbon dating places the oldest structures at approximately 9,600 BCE, making them contemporary with the end of the Younger Dryas and the beginning of the Holocene epoch. At this time, according to conventional archaeology, humans in this region were still living as nomadic hunter-gatherers, subsisting on wild plants and game, living in temporary shelters, and possessing no centralized social organization beyond family groups or small bands. They had not yet domesticated plants or animals. They had not yet invented pottery or developed permanent settlements. They had not yet created the agricultural surplus that supposedly provides the foundation for specialized labor, social hierarchy, and monumental architecture. Yet somehow these people quarried, transported, carved, and erected stones weighing up to 20 tons, arranged them in complex geometric patterns, decorated them with sophisticated relief carvings, and did all of this not once, but repeatedly, creating multiple temple structures across the site. The logistics alone are staggering. The pillars were quarried from limestone bedrock located on the hill itself, but moving them from the quarry to their final positions required coordinated effort from dozens or hundreds of people. There are no signs of wheels, no evidence of metal tools, no indication of the mechanical advantages that later civilizations would use to move massive stones. The workers would have used stone tools, wooden levers, and human muscle, techniques that require not just physical strength, but engineering knowledge, understanding of leverage, weight distribution, and structural stability. This was not random stone stacking. This was architecture, deliberate and sophisticated, requiring planning that extended over years or decades, and coordination of labor that implies social structures capable of organizing and feeding large workforces. But the true mystery of Göbekli Tepe is not merely its age or the size of its stones. It is the question of why it was built. Most monumental architecture serves practical purposes: temples for established religions, palaces for rulers, defensive walls for cities, tombs for the elite. Göbekli Tepe appears to be purely ceremonial, a place designed for gathering, ritual, and possibly astronomical observation. There are no signs of permanent habitation at the site, no domestic structures, no evidence of daily living activities like cooking or tool production. People came to Göbekli Tepe from elsewhere, perhaps traveling considerable distances, to participate in whatever activities occurred within these stone circles, and then they left. The site was a destination, not a settlement, which raises the question, what could motivate nomadic hunter-gatherers to invest the enormous effort required to build such a place? The carvings on the pillars provide clues that are simultaneously illuminating and disturbing. Many of the reliefs depict predatory animals, creatures that would have posed threats to humans: lions, leopards, snakes, scorpions. Others show scavengers like vultures, often in positions above human heads or headless human figures. One of the most striking images found on Pillar 43 in Enclosure D shows a series of animals arranged around what appears to be a circular or radial pattern, with a scorpion at the bottom and a vulture with outstretched wings at the top. Some researchers have interpreted this as an astronomical chart, a representation of constellations, as they appeared in the sky 11,600 years ago. The arrangement corresponds to constellations visible during the summer solstice of that era, suggesting that the builders possessed detailed knowledge of celestial movements and seasonal cycles. If the pillar carvings are astronomical records, they imply something profound. The people who built Göbekli Tepe were not simply reacting to their immediate environment, hunting and gathering day to day. They were observing the sky over long periods, tracking the movements of stars and planets, recognizing patterns that required multi-generational observation. This is not the behavior of nomadic bands struggling for survival. This is the behavior of a culture with enough stability, enough surplus time, and enough accumulated knowledge to engage in abstract intellectual pursuits, to care about what the sky was doing, and to record that information in permanent form. And if they possess this knowledge at the end of the Younger Dryas, it raises the question, where did they learn it? Did they discover these patterns themselves? Developing astronomy from scratch in the centuries immediately following the climate catastrophe? Or did they inherit this knowledge from an earlier source, from survivors who carried with them the observations and calculations of a previous age? There is another detail that cannot be ignored. Göbekli Tepe was deliberately buried. Around 8000 BCE, after approximately 1,600 years of use, the entire complex was filled in with rubble and soil, covering the pillars and enclosures completely. This was not abandonment due to war, environmental change, or population collapse. This was intentional preservation, a decision to hide the site beneath the earth. The effort required to bury Göbekli Tepe would have been nearly as substantial as the effort to build it, requiring tons of fill material to be transported and deposited over the structures. Someone wanted to ensure that these stone circles remained intact, protected beneath the ground, either as a time capsule for future generations or as a sacred site too powerful to leave exposed. The deliberate burial suggests that the site held significance beyond its physical presence, that it represented something so important that even after centuries of use, it could not simply be walked away from and forgotten. The existence of Göbekli Tepe forces a fundamental reconsideration of the relationship between agriculture, settlement, and civilization. The orthodox narrative tells us that agriculture came first, creating food surpluses that allowed populations to settle in permanent villages, which then led to social stratification, specialized labor, and eventually monumental architecture. But Göbekli Tepe inverts this sequence. The monument came first, built by people who were still hunters and gatherers, and only later, centuries after the temples were constructed, do we see evidence of agriculture beginning in the surrounding region. This suggests that the motivation for settling down, for developing farming, was not simply the practical need for more reliable food sources. It was the need to support the construction and maintenance of sacred sites, to feed the workforces that built the temples, to create the social structures necessary for large-scale ritual activities. Religion, or whatever drove the construction of Göbekli Tepe, may have been the catalyst for civilization, not its consequence. If that interpretation is correct, it raises a question that cuts to the heart of this entire investigation. What were they commemorating? What event or knowledge was so significant that it required monumental architecture to preserve its memory? The date is telling. Göbekli Tepe was built at the end of the Younger Dryas, at the moment when the climate stabilized after 1,300 years of glacial conditions. It was built by people who would have lived through the final phases of the catastrophe or who inherited immediate memory of it from their parents and grandparents. If the cataclysm hypothesis is correct, if the Younger Dryas was triggered by cosmic impact and if that impact destroyed advanced coastal civilizations, then Göbekli Tepe may be a memorial, a sanctuary built by survivors or their descendants to honor what was lost and to preserve the knowledge that remained. The astronomical alignments, the animal carvings, the geometric precision, these may be fragments of inherited understanding, pieces of a larger knowledge system that the builders were attempting to encode in stone so that it would survive even if oral tradition failed, even if memory faded, even if another catastrophe came. The evidence accumulating in the Younger Dryas boundary layer is not random noise or statistical artifact. It is a coherent pattern of materials that appear together at the same stratigraphic depth across multiple continents, forming what researchers call an impact signature. For decades, mainstream geology resisted the idea that cosmic impacts could have played a significant role in recent Earth history, preferring explanations rooted in gradual processes: volcanism, climate oscillation, tectonic shifts. But the materials found at the 12,900-year boundary do not form gradually. They form instantaneously under conditions of extreme violence that occur naturally only when extraterrestrial objects collide with Earth's atmosphere or surface. The presence of these materials simultaneously across North America, Europe, and parts of Asia suggests not a localized event, but multiple impacts or airbursts occurring within a narrow time window, a cosmic bombardment that would have appeared to observers on the ground as the sky itself catching fire. The Comet Research Group, an international collaboration of scientists from multiple disciplines including geology, physics, astronomy, and archaeology, has been systematically documenting these impact markers since the early 2000s. Their work represents a fundamental challenge to uniformitarian geology, the principle that Earth's history can be explained primarily through slow, continuous processes rather than catastrophic events. The group's findings include nanodiamonds, carbon structures measuring only a few nanometers across, formed when carbon-bearing materials are subjected to pressures exceeding 100 gigapascals and temperatures exceeding 2,000 degrees Celsius. These conditions occur naturally during meteor impacts when shock waves compress and superheat material in fractions of a second. Nanodiamonds have been identified at over 50 sites within the Younger Dryas boundary layer, from California to Belgium, from Syria to Venezuela, all dated to the same narrow time window at the onset of the climate collapse. Shocked quartz provides another line of evidence. When quartz crystals experience extreme pressure, typically above 10 gigapascals, they develop distinctive planar deformation features, parallel fracture planes running through the crystal lattice at specific angles. These features do not form from normal geological stress, and volcanic activity or tectonic compression. They form during hypervelocity impacts when shock waves propagate through rock faster than the speed of sound, creating pressures that momentarily exceed anything experienced in normal crustal processes. Shocked quartz grains have been found in Younger Dryas boundary sediments across North America and Europe, their presence impossible to explain through conventional geology. The grains are not weathered or rounded from long transport. They are fresh, angular, and chemically pristine, indicating they were deposited rapidly, directly from the source event rather than being reworked through erosion and redeposition over long periods. Magnetic spherules and microspherules present perhaps the most visually striking evidence. These are tiny beads of melted rock and metal, ranging from microscopic sizes up to a few millimeters in diameter, formed when impact energy vaporizes or melts material that then cools rapidly while airborne or in water, forming perfect spheres due to surface tension. The composition varies, but many contain high concentrations of iron, nickel, and other metals in ratios consistent with cosmic material rather than terrestrial sources. The spherules appear in concentrations far exceeding background levels, sometimes numbering in the thousands per kilogram of sediment. Their distribution pattern suggests they fell from the atmosphere like rain after being ejected high into the stratosphere by impact events, then settling globally over weeks or months as the atmosphere cleared. Platinum group element anomalies provide geochemical confirmation of extraterrestrial input. Platinum, iridium, osmium, and related elements are rare in Earth's crust, but relatively abundant in asteroids and comets. When cosmic objects strike Earth, they deliver these elements in detectable concentrations. The Younger Dryas boundary shows platinum spikes reaching levels up to 100 times higher than background, measured at sites across multiple continents. The enrichment pattern matches what we would expect from cosmic impact material rather than volcanic or anthropogenic sources. Volcanic activity can produce some platinum enrichment, but not at these magnitudes and not with the global distribution observed in the boundary layer. The platinum is there because something from space delivered it, violently and suddenly, at the onset of the Younger Dryas. The distribution pattern of these materials suggests the impactor was not a single asteroid or comet nucleus, but a fragmented object, possibly a disintegrating comet that had broken into multiple pieces before encountering Earth. This scenario would explain why impact markers appear across such a broad geographical range, rather than being concentrated around a single crater. Each fragment, ranging perhaps from dozens of meters to several kilometers in diameter, would have entered the atmosphere on a shallow trajectory, exploding as an airburst or striking the surface depending on its composition and velocity. The Tunguska event of 1908 provides a modern analogue. An object estimated at 50 to 100 meters in diameter exploded over Siberia, with energy equivalent to 10 to 15 megatons of TNT, flattening 2,000 square kilometers of forest without leaving a traditional impact crater. Scale that event up by orders of magnitude, multiply it across a continent, and you approach the kind of catastrophe implied by the Younger Dryas impact hypothesis. The thermal effects alone would have been apocalyptic. Computer simulations of multiple airbursts occurring over the Laurentide ice sheet suggest that the combined thermal radiation could have melted trillions of tons of ice within hours, releasing catastrophic floods and raising sea levels by meters in a matter of days. The heat would have ignited biomass across hundreds of thousands of square kilometers, creating firestorms that consumed forests, grasslands, and any settlements in their path. The atmospheric injection of soot, dust, and aerosols from the fires and impacts would have blocked sunlight, triggering rapid cooling even as the ground below remained devastated by fire. This combination of immediate incineration followed by prolonged cold explains the seemingly contradictory evidence in the geological record. Charcoal and burned material in the same layers that mark the onset of glacial conditions. The Comet Research Group has also identified high-temperature minerals in the boundary layer, including melted glass and minerals that form only above 1,700 degrees Celsius, temperatures far exceeding anything produced by wildfires or volcanic activity at the surface. These materials indicate that portions of the landscape were subjected to thermal pulses comparable to those experienced near nuclear detonations, consistent with airburst scenarios where the impactor explodes at altitude, focusing energy downward in a directed blast. The presence of these high-temperature minerals at sites far inland, away from any volcanic activity, points to an atmospheric source of extreme heat, not a ground-based source. Critics of the impact hypothesis have argued that some of these materials could have alternative explanations, that nanodiamonds might form through other processes, that platinum anomalies could come from volcanic sources, that spherules might be industrial contamination. But these criticisms must address the convergence of evidence, the fact that all of these markers appear together at the same stratigraphic boundary across multiple continents, in contexts where industrial contamination is impossible and volcanic sources are absent. The pattern is too coherent, too geographically widespread, and too temporally constrained to be coincidence or misinterpretation. Something catastrophic happened 12,900 years ago, something involving extreme heat, pressure, and the delivery of extraterrestrial material to Earth's surface. The astronomical context supports the impact hypothesis. Earth passes through debris fields left by disintegrating comets regularly, experiencing meteor showers when these particles enter the atmosphere. Most are small, burning up harmlessly as shooting stars, but occasionally Earth encounters larger fragments. The torrid meteor stream, which Earth passes through twice annually, is associated with Comet Encke, a short-period comet whose orbit crosses Earth's path. Some astronomers have proposed that this stream contains not just dust and small particles, but also larger, potentially hazardous objects, remnants of a much larger comet that broke apart thousands of years ago. The timing of Earth's passage through the densest portions of this debris field could align with periods of increased impact risk, including potentially the Younger Dryas boundary. What emerges from this evidence is not certainty, but probability. The materials are real, documented in peer-reviewed literature, analyzed in laboratories across the world. The distribution is global, the timing is precise, and the implications are profound. If Earth was struck by fragments of a disintegrating comet at the onset of the Younger Dryas, then the climate collapse, the megafaunal extinctions, and the cultural disruptions visible in the archaeological record all become connected consequences of a single catastrophic event. And if coastal civilizations existed during the Ice Age, thriving on lands now submerged, they would have been in the direct path of the devastation, watching the sky burn and the seas rise, forced to flee or perish. The cosmic impact hypothesis does not prove Atlantis was real, but it provides a mechanism for how such a civilization could have been destroyed, rapidly and completely, leaving only survivors to carry fragments of memory into a world that had forgotten. During the last ice age, when glaciers covered Canada, Scandinavia, and much of northern Europe, global sea levels were approximately 400 feet lower than they are today. This is not speculation or theoretical modeling. This is measured fact, confirmed by sediment cores, coral growth patterns, and the exposed continental shelves visible on bathymetric maps of the ocean floor. 400 feet of vertical drop translates to hundreds of miles of horizontal coastline, vast stretches of land that were above water during the Ice Age but now lie beneath the sea. These submerged coastal plains would have been prime real estate for human habitation, temperate, resource-rich, with access to both marine and terrestrial food sources, sheltered from the harsh conditions of the glacial interior. If advanced civilizations existed during the Ice Age, this is where they would have built their cities, along coastlines that are now 300 feet underwater, drowned when the ice sheets collapsed and the seas rose in catastrophic pulses during the Younger Dryas and its aftermath. Orthodox archaeology has largely ignored the possibility of Ice Age coastal civilizations for a simple reason. The evidence, if it exists, is underwater, inaccessible to traditional archaeological methods, buried beneath sediment and coral growth, corroded by millennia of saltwater exposure. Excavating underwater sites requires specialized equipment, technical diving skills, and funding that most archaeological institutions cannot or will not allocate to what they consider speculative searches. As a result, the submerged continental shelves, which represent roughly 8% of the total land area that existed during the Ice Age, remain almost entirely unexplored. We have better maps of the surface of Mars than we do of these drowned landscapes. But in the few locations where marine archaeologists and independent researchers have looked, they have found anomalies, structures that do not fit comfortably into explanations of natural geological formation. Off the coast of Yonaguni, the southernmost island of Japan, divers in 1986 discovered a massive underwater formation that has generated decades of debate. The structure, lying at depths between 15 and 100 feet, consists of flat terraces, right-angle corners, vertical walls, and what appear to be carved steps and pathways. The formation is approximately 300 feet long and 90 feet wide, rising from the seafloor in distinct tiers that suggest architectural intention rather than random erosion. Proponents of the artificial origin hypothesis point to features that are difficult to explain geologically: parallel grooves that run across multiple terraces, circular holes that appear to have been carved rather than formed by water action, and the overall geometry of the site, which resembles a stepped pyramid or ziggurat. Critics argue that sandstone formations can fracture along natural planes, creating features that mimic architectural patterns without requiring human intervention. But the concentration of these features in a single location, the alignment of edges and corners, and the presence of what appear to be access routes and platforms suggest that even if the base structure is natural, it may have been modified, shaped, and utilized by humans. The dating of the Yonaguni structure aligns disturbingly well with the Younger Dryas timeline. The site would have been above sea level until approximately 10,000 years ago, when the final meltwater pulses raised the ocean and submerged the southern coast of Japan. If the structure was built or modified while the land was exposed, it would have been abandoned and drowned during the climate catastrophe, left intact beneath the rising waters. The lack of archaeological artifacts at the site, which critics cite as evidence against human construction, might actually support the drowning hypothesis. If inhabitants knew the waters were rising, if they watched the sea encroaching over years or decades, they would have evacuated, taking their portable possessions and leaving only the stone architecture behind. What we see today might be the bones of a site stripped clean by evacuation and then preserved by submersion, protected from the erosion and human disturbance that destroys surface ruins over millennia. Off the coast of Mahabalipuram in southern India, divers have documented stone structures lying 30 to 40 feet underwater, including what appear to be walls, foundations, and carved blocks arranged in patterns suggesting urban planning. Local legends speak of 7 pagoda temples, 6 of which were swallowed by the sea, leaving only the shore temple visible above water. These legends, dismissed as myth by colonial-era scholars, gained credibility when the 2004 tsunami briefly receded the water near shore, revealing carved stone foundations and sculptures that had been hidden beneath sand and shallow water. Subsequent underwater surveys confirmed the presence of extensive structural remains extending offshore, including linear walls, rectangular formations, and carved stone blocks that do not appear to be natural beach rock. Radiocarbon dating of organic material found in association with the structures suggests ages ranging from 5,000 to 10,000 years, pushing the timeline of sophisticated construction in this region back into periods that predate the supposed beginning of Indian civilization. The Gulf of Cambay, also called the Gulf of Khambhat, off the western coast of India, presents another underwater anomaly. Side-scan sonar surveys conducted in the early 2000s revealed what appeared to be an extensive urban grid lying 120 feet below the surface, covering an area of 5 miles by 2 miles. The sonar images showed rectilinear features, perpendicular intersections, and geometric patterns inconsistent with natural seabed topography. Artifacts recovered from the site by dredging operations included pottery, stone tools, and wooden beams, some of which returned radiocarbon dates of over 9,000 years, placing them in the pre-Harappan period, long before the Indus Valley civilization supposedly emerged. The site remains controversial, with critics questioning whether the sonar images truly represent artificial structures or are being over-interpreted, and whether the dated artifacts are genuinely in situ or were displaced by dredging. But the possibility remains that an extensive urban settlement lies beneath the Gulf of Cambay, drowned when sea levels rose after the Ice Age. Its existence preserved in local flood legends and now being rediscovered through marine archaeology. Off the coast of Cuba, near the western tip of the island, marine geologists conducting surveys in 2000 discovered sonar images of what appeared to be massive stone blocks, arranged in geometric patterns at depths of 2,000 feet. The formations included what looked like pyramidal structures, circular shapes, and linear arrangements covering an area of several square kilometers. The depth is problematic. For these structures to have been built above water would require sea levels 2,000 feet lower than present, a condition that last existed over 50,000 years ago, far beyond the timeline of known human civilization. Skeptics have argued that the formations are natural, possibly volcanic or tectonic features that happen to display geometric patterns. But the discovery team maintained that the symmetry, right angles, and apparent organization of the blocks suggest artificial origin, calling for detailed investigation. Funding and political complications have prevented extensive follow-up surveys, leaving the Cuba structures as an unresolved anomaly, tantalizing but unconfirmed. The Mediterranean Sea, cradle of ancient civilizations, also harbors submerged mysteries. Off the coast of Alexandria, Egypt, divers have mapped extensive ruins of the ancient city's harbor, including colossal statues, columns, and building foundations now lying beneath 20 to 30 feet of water. While much of this submersion is attributed to earthquakes and subsidence over the past 2,000 years, some structures appear to predate the accepted founding of Alexandria, suggesting earlier occupation of the site. Near the island of Malta, underwater surveys have documented what appear to be megalithic structures similar to the famous temples on the island's surface, but now submerged offshore, implying that the temple-building culture extended onto lands that are now underwater. The submersion of these sites would have occurred during the post-Ice Age sea level rise, between 10,000 and 6,000 years ago, suggesting that Malta's megalithic culture might be older and more extensive than surface archaeology alone indicates. The common thread connecting these underwater discoveries is not proof of Atlantis in a literal sense, but evidence that human occupation of coastal regions during the Ice Age was more extensive than orthodox archaeology acknowledges. If people were living on these coastlines, building structures from stone, developing urban layouts, and creating art and architecture, then when the seas rose, their civilizations would have been destroyed, their populations forced inland, their knowledge fragmented. The survivors would have carried memories of the drowned lands, stories of great cities swallowed by the sea, narratives that would eventually become the flood myths we find in every culture. The underwater ruins are not definitive proof of advanced Ice Age civilization, but they are evidence that humans were doing more than hunting and gathering on those coastlines. They were building, organizing, and possibly achieving levels of social complexity that vanished beneath the waves when the ice melted and the world drowned. If a civilization was destroyed at the end of the Ice Age, erased by cosmic impact and rising seas, then the story does not end with destruction. It continues with the survivors, the scattered remnants who fled inland when the coastlines drowned, who watched their cities burn and their world collapse, who carried with them not just their lives, but something more precious and more fragile: memory. Not the memory of personal trauma, though, that certainly travelled with them, but the memory of what had been achieved before the catastrophe, the accumulated knowledge of astronomy, mathematics, engineering, agriculture, and social organization that had taken generations or centuries to develop. These survivors faced a choice that would determine the trajectory of human civilization for the next 10,000 years. They could let the knowledge die with them, accepting that the world had ended and that humanity must start again from nothing. Or they could preserve what they could, encode it in whatever forms would survive, and pass it forward to descendants who might not understand its origins, but who could use it to rebuild. The evidence suggests they chose preservation. When we examine the earliest civilizations that emerge into the light of recorded history, Sumer in Mesopotamia, Egypt along the Nile, the Indus Valley in what is now Pakistan, we do not see gradual development from primitive beginnings. We see societies that appear already sophisticated, already in possession of knowledge that seems to have no developmental precursor in the archaeological record. The Sumerians appear around 3200 BCE with a fully developed writing system, complex mathematics including place value notation, and the concept of zero, astronomical observations that track planetary movements with precision, and engineering capable of building cities with irrigation systems, monumental architecture, and defensive walls. There is no apprenticeship period visible in the record, no centuries of slowly improving pottery or tentatively experimenting with agriculture. They arrive on the historical stage already competent, as if they inherited a blueprint rather than invented one. The mathematical sophistication of early Sumerian tablets is particularly revealing. Clay tablets dating to the Old Babylonian period around 2000 BCE contain mathematical tables that include not just basic arithmetic but trigonometric calculations, Pythagorean triples, and algorithms for computing square roots and cube roots that are functionally identical to methods used in modern mathematics. One tablet, catalogued as Plimpton 322, contains a table of what appear to be Pythagorean triples, sets of three integers that satisfy the relationship where the square of the hypotenuse equals the sum of the squares of the other two sides. This is not elementary mathematics. This is advanced number theory, requiring understanding of algebraic relationships and geometric principles that Orthodox history claims were not formalized until the Greeks developed them over 1,000 years later. The Sumerians were not fumbling toward mathematical understanding. They possessed it, fully formed, recorded in cuneiform on clay as if copying from an older source. Their astronomical knowledge presents the same pattern. Sumerian and later Babylonian astronomical tablets track the movements of Venus, Mars, Jupiter, and Saturn, with observations spanning centuries. They calculated the synodic periods of planets, the time it takes for a planet to return to the same position relative to Earth, with accuracy that requires multi-generational observation and record-keeping. They divided the circle into 360 degrees, the day into 24 hours, the hour into 60 minutes, using a sexagesimal numerical system based on the number 60 that we still use for measuring time and angles today. This system is not arbitrary. It is mathematically elegant, allowing for easy division by many factors, suggesting that whoever developed it understood number theory at a sophisticated level. But where did they learn it? If the Sumerians invented this system themselves, where is the evidence of experimentation, the earlier tablets showing trial and error, the gradual refinement of an idea? The system appears fully formed in the earliest documents, as if inherited rather than invented. Egypt presents similar anomalies. The Great Pyramid of Giza, built around 2560 BCE, according to Orthodox chronology, demonstrates engineering precision that modern construction struggles to replicate. The base of the pyramid is level to within 2 centimeters across a footprint covering 13 acres. The sides are aligned to the cardinal directions within 3/60ths of a single degree, an accuracy that requires astronomical observation and understanding of true north versus magnetic north. The dimensions of the pyramid encode mathematical relationships. The ratio of the perimeter to the height approximates 2 times pi, the ratio that relates a circle's circumference to its radius. The structure sits at latitude 29.979 degrees north, approximately 1/300th of the distance from the equator to the North Pole, a placement that seems too precise to be coincidental. This is not the work of a civilization in its infancy, slowly learning to work stone and stack blocks. This is the work of a civilization that already understood geometry, astronomy, and engineering at a level that suggests inheritance of knowledge from an earlier source. The architectural precision extends to megalithic sites worldwide. At Machu Picchu in Peru, at Tiwanaku in Bolivia, at Baalbek in Lebanon. At dozens of other locations across the planet, we find stone construction that utilizes techniques eerily similar, despite being separated by oceans and supposedly developing independently. These sites feature massive stones, some weighing hundreds of tons, cut with precision that leaves joints so tight that a knife blade cannot fit between blocks. They show evidence of advanced stoneworking techniques, including the use of complex interlocking shapes, polygonal masonry that distributes stress across irregular patterns, and a level of planning that requires understanding of structural engineering and material properties. Orthodox archaeology attributes these similarities to convergent evolution, the idea that different cultures independently discovered the same solutions, but the convergence is suspiciously perfect, not just in technique, but in execution, as if these separate cultures were all working from the same lost instruction manual. The megalithic sites also demonstrate astronomical alignment with consistent precision. Stonehenge in England, the pyramids of Giza, the temples of Angkor Wat in Cambodia, Chichen Itza in Mexico, all incorporate orientations that align with solstices, equinoxes, or specific stellar events. This preoccupation with astronomy, with tracking the movements of celestial bodies, and encoding those observations in permanent architecture, suggests that these cultures considered astronomical knowledge essential, worth preserving in stone even when parchment and papyrus would decay, even when oral tradition might fail. The alignment of sacred structures with the sky is not decoration or religious symbolism alone. It is mnemonic architecture, a way of embedding knowledge into the landscape, so that even if language changed, even if writing was lost, even if cultural continuity was disrupted, the information would remain accessible to anyone who learned to read the stones. The preservation of knowledge after catastrophe requires deliberate effort and cultural institutions dedicated to maintaining information across generations. The Egyptian priesthood, the Brahmin caste in India, the Mayan astronomer priests, all represent social structures designed to protect specialized knowledge from loss. These were not just religious leaders performing rituals. They were archivists, mathematicians, astronomers, keepers of calendars and agricultural schedules, maintainers of building techniques and medical practices. They were the institutional memory of their societies, and their authority derived not from political power, but from their monopoly on knowledge that was essential for civilization to function. If these institutions inherited rather than invented their knowledge, if they received it from predecessors who survived the Younger Dryas catastrophe, then their obsessive concern with preservation, their encoding of information in multiple redundant forms, their training of successors through rigorous apprenticeship, all make perfect sense. They were not just maintaining tradition, they were preventing extinction of knowledge that had already been lost once. The myths support this interpretation. Stories from around the world describe culture heroes, mysterious teachers who arrive after the flood, bearing knowledge of agriculture, astronomy, writing, and law. These figures are described as different from the local populations, sometimes bearded in regions where beards are uncommon, sometimes arriving from across the sea, sometimes explicitly stated to be survivors from a previous age. They teach, establish social order, build foundational structures, and then disappear, leaving behind institutions and knowledge that become the basis of the emerging civilization. Osiris in Egypt, Quetzalcoatl in Mesoamerica, Viracocha in South America, Oannes in Mesopotamia, all fit this pattern. Orthodox scholars dismiss these as mythological archetypes, symbolic representations of the civilizing process. But what if they are memory, distorted by time but preserving the essence of what happened? That the knowledge which founded civilization was not invented by those who first emerge into recorded history, but inherited from survivors who carried it forward from a world that drowned. We return now to the question that opened this investigation, but with a different understanding of what we are asking. Was Atlantis real? The answer is not a simple yes or no, because Atlantis is a name given by Plato to something he heard about through Egyptian sources, filtered through Solon, translated through time and language, possibly corrupted by transmission errors and cultural interpretation. The name might be wrong. The location might be imprecise. The specific details about concentric rings and orichalcum-covered walls might be embellishments added to make the story more vivid or memorable. But beneath the names and the mythological overlay, there is a pattern of evidence that refuses to be dismissed. There is geological proof of catastrophic climate collapse 12,900 years ago. There is impact material in the sediment layers, nanodiamonds and shocked quartz and platinum anomalies that mark the moment when something from space struck the Earth with enough force to destabilize the planetary climate system. There is the black mat layer stretching across continents, recording synchronized destruction and abandonment of human settlements. There are flood myths preserved in over 200 cultures, all describing the same sequence of advanced societies destroyed by inundation. There are underwater ruins lying where coastlines existed during the Ice Age, now drowned beneath hundreds of feet of seawater. And there are the inexplicable sophistications of the earliest civilizations, appearing already developed, already possessing mathematical and astronomical knowledge that seems to have no developmental history. As if inherited rather than invented. What this evidence suggests is not that Plato's account is literally true in every detail, but that it preserves memory of something that was real. A civilization or multiple civilizations that existed during the Ice Age on coastlines now submerged, that achieved levels of sophistication we associate with later societies, that possessed knowledge of astronomy, mathematics and engineering, and that were destroyed when cosmic impact triggered the Younger Dryas climate collapse and the subsequent sea level rise drowned their coastal territories. The survivors of that catastrophe, displaced inland, carrying fragments of lost knowledge, became the culture heroes and mysterious teachers described in myths worldwide. The founders of the post-Diluvian civilizations that emerge into recorded history, already possessing skills and understanding that appear impossibly advanced for their supposed stage of development. Atlantis, whether or not that was ever its real name, was not mythology. It was memory, distorted by 12,000 years of retelling, but memory nonetheless of a world that existed and ended. But the purpose of this investigation is not simply to rehabilitate an ancient legend or to prove that orthodox archaeology has overlooked important evidence. The purpose is to understand what the destruction of that previous civilization means for ours. Because if advanced societies have risen and fallen before, if knowledge can be lost so completely that it survives only as myth and fragment, if planetary catastrophe is not anomaly, but pattern, then we must confront the possibility that our own civilization is not the permanent achievement we assume it to be, but another temporary arrangement, another experiment in complexity that exists at the mercy of forces we do not control and barely understand. The geological record shows that Earth has been struck by cosmic objects repeatedly throughout its history. The Younger Dryas impact was not the first, and will not be the last. The Tunguska event of 1908, when an object exploded over Siberia with the force of 15 megatons, flattening 2,000 square kilometers of forest, was a reminder that the threat is not theoretical. The Chelyabinsk meteor of 2013, which exploded over Russia with energy equivalent to 500 kilotons, injuring over 1,000 people from the shockwave alone, was another reminder. These were small objects measured in tens of meters. The Younger Dryas impactor, if the hypothesis is correct, was orders of magnitude larger, a fragmented comet whose pieces struck across continental scales. Modern astronomy has identified numerous near-Earth objects, asteroids and comets whose orbits cross Earth's path, that pose potential collision risks. Space agencies track these objects, calculate their trajectories, and assess the probability of impact. But the tracking is incomplete. We see only the objects large enough and bright enough to be detected with current telescopes. Smaller objects, dark objects, comets on long-period orbits approaching from the outer solar system can arrive with little warning. The capability to deflect an incoming impactor exists in theory, through kinetic impactors or gravity tractors or nuclear detonations, but has never been tested at the scale that would be required for a real planetary defense scenario. If an object the size of the Younger Dryas impactor were discovered on a collision course with Earth today, our civilization would have little ability to prevent the catastrophe and limited capacity to survive its consequences. The fragility extends beyond cosmic threats. Our civilization is dependent on systems that are globally interconnected and locally vulnerable. The electrical grid that powers modern life is susceptible to disruption from solar storms, electromagnetic pulses, or cascading failures that could take years to repair. The global food supply relies on industrial agriculture, just-in-time shipping, and chemical inputs that depend on complex supply chains vulnerable to disruption. The internet and communication networks that coordinate economic activity and social organization run on infrastructure that requires constant maintenance and is concentrated in vulnerable nodes. A catastrophe on the scale of the Younger Dryas, whether from cosmic impact, supervolcanic eruption, or some other planetary trauma, would not just kill billions in the immediate event. It would collapse the systems that allow the survivors to rebuild. The knowledge encoded in digital formats would be inaccessible without electricity. The specialized expertise required to manufacture pharmaceuticals, computer chips, or advanced materials is distributed across global networks that would no longer function. Within a generation or two, the survivors would be reduced to subsistence agriculture and basic metallurgy. Not because they are less intelligent than their ancestors, but because the knowledge required to sustain technological civilization is not stored in individual brains. It is stored in institutions, in books and databases, in the accumulated expertise of specialists, all of which are vulnerable to disruption. This is what the ancient myths are trying to warn us about. The flood narratives are not just historical accounts of a specific catastrophe. They are warnings that civilizations fall, that knowledge is lost, that the world resets, and that the survivors are left to rebuild from fragments. The emphasis in these myths on preserving knowledge, on saving books or sacred objects or craftsmen, reflects the understanding that what is lost in a catastrophe is not just lives, but the accumulated wisdom of generations. The culture heroes who appear after the flood, bearing knowledge, are representations of what must happen for civilization to continue. Someone must remember, someone must preserve, someone must pass forward what would otherwise be forgotten. And the fact that these myths exist across so many cultures suggests that this cycle has happened repeatedly, that civilizations have risen to sophistication, been destroyed by catastrophe, and forced their survivors to restart from primitive conditions, losing most of what had been achieved, but retaining enough fragments to eventually rebuild. We are not immune to this cycle. Our technology, our global population, our dependence on complex systems, all of these make us powerful but also fragile. A catastrophe that destroys infrastructure would leave billions without food, water, medicine, or shelter, creating a humanitarian crisis that no remaining institutions could address. The survivors would face the same choice the Younger Dryas survivors faced: let knowledge die or preserve what can be saved. But we have an advantage our ancestors did not. We know the cycle exists. We have decoded the geological record and can read the warnings written in sediment layers and ice cores. We have the technological capability, if we choose to invest in it, to detect incoming threats and possibly to deflect them. We have the ability to create redundant archives of knowledge, distributed across multiple formats and locations, designed to survive catastrophe and remain accessible to survivors. We can encode information in ways that do not require electricity or specialized equipment to access, creating a library of essential knowledge that could help future generations rebuild faster than our ancestors did. But doing this requires acknowledging that we are vulnerable, that catastrophe is possible, that our civilization is not permanent. It requires investing resources in projects that benefit not us, but potential future survivors, people who may or may not ever exist, depending on whether the catastrophe comes in our lifetime or in some distant future century. It requires humility, the recognition that we are not the culmination of history, but another chapter in a longer story. A story that includes previous chapters we have forgotten and future chapters we may not survive to see written. The flood myths, the underwater ruins, the impact evidence in the Younger Dryas boundary layer, the inexplicable sophistication of early civilizations, all of this is not just about the past, it is about the future. It is a warning encoded in geology and myth, preserved through 12,000 years, telling us that the world has ended before and will end again, and that the only thing that prevents total loss is memory, the decision to preserve and pass forward what we know, so that those who come after, whoever and whenever they are, do not have to start from zero. Atlantis, whether it was real or not, whether it was called by that name or some other name lost to time, represents the possibility that we are not the first and will not be the last. The cycle waits in the dark, written in the orbits of comets and asteroids, in the instability of ice sheets and the volatility of the planetary climate system. The question is not whether catastrophe will come. The question is whether we will remember, whether we will preserve, whether we will prepare, and whether, when the survivors of the next catastrophe search the ruins of our civilization for answers, they will find fragments of knowledge that help them rebuild, or only silence and sand and the drowned coastlines of a world that forgot to warn itself.
If you enjoyed the video, hit the like button, subscribe, and activate notifications so you don't miss our next videos.